Today we are looking at a chemical reaction called electrolysis, where we're using electricity to break apart a molecule called copper to chloride, and we are making pure copper and chlorine gas. Here is the solution at the start of the experiment. We have the red electrode being the positive electrode and the black electrode being the negative, and we have a copper chloride solution, that is copper chloride mixed into distilled water and stirred up. It gives that blue color because there are copper ions in the solution. The water splits the copper to chloride molecules apart and we get ions floating. Here we have the reaction running 3 hours into the experiment. You can see there are bubbles on the right hand electrode, and on the other electrode we have pure copper being attracted to the negative electrode. That is because the copper ions are positively charged and they are attracted to the negative, and the chlorine is attracted to the positive electrode because the chlorine ions are negative. Here we're about 9 hours in, and you can see that the blue color is gradually fading, we are getting more and more copper visible, and always the chlorine gas being given off. When you run this experiment, you can actually smell it. It smells like a swimming pool that has had chlorine dosed into it, and there you can see the bubbles being given off with plenty of copper on the other electrode. Here we can follow the red wire, and you can see that it will lead to the positive terminal of my DC power supply in the classroom, and then the black lead there runs from the negative terminal to the electrode that is getting all the copper deposited. So the positive copper ions are being attracted to the negative electrode, and the negative chlorine ions are attracted to the positive electrode.
Right guys, we're now Wednesday afternoon. I started running this practical on Monday, and I'm zoomed right up here on the positive electrode because I want you to see how slow the bubbles are being given off, and you can see how much copper is on the negative electrode. So there's a lot of copper being pulled out of solution. There has been a lot of chlorine gas given off, and just look at the color of the solution. Here we go. Here's the comparison. That's a fresh solution. Okay, I haven't run any current through that solution, and that's what those electrodes would have looked like. And now, after a third school day of running, you can see just how slow the reaction is, how much has been pulled out of the solution, and how we have lost the color. Right guys, it's now Thursday morning. Started this prac running on Monday morning. There's what the solution looked like when we started, and obviously it's only able to run during the school day while I'm here to watch it, but you can see how slow the production of bubbles is. Once I think it's finished, I am going to put some fresh solution and compare the bubble rate, which I will clip onto the end of this video. But you can obviously see the machine is still on, and you can see the terminals there. Right, so the red terminal where the chlorine is given off is your positive terminal, and the black terminal is your negative terminal, and hence all the copper being deposited. Right, so we got both solutions running, and the fresh one, you can see I've just had it running for a short period of time with my class here, and there you can see the copper starting to coat the electrodes. Probably easy if I pull the camera a little bit away. So that's the reaction just starting, and the reaction that is furthest away from the camera is finished. You can see there are no longer any bubbles being formed. The reaction is done. There are no electrolytes available in the solution, and hence the solution is no longer conducting electricity. Whereas here we are conducting electricity. You can see that because bubbles are being produced and the copper is being deposited onto the electrode. There you go. Okay, and that one, I think that ran for about 12 hours to get it to look like that. Right guys, so you can see the power is on here, and there's no reaction happening anymore, or maybe there just are very few bubbles forming there. I don't know how, no, I don't think there are. I think the reaction is completely finished. You can see the color of the solution is completely clear, but we've got loads of copper. And if I look at it from above, you can see how reddy brown it looks, all the copper that's in there. As I said, power's still on, so it's still trying to run current through, but there's no longer any electrolytes present in the solution, so it will no longer conduct electricity. And our chemical reaction is finished.
And here is what the solution and the electrodes look like when we started. Clean black electrodes and a bright blue copper 2 chloride solution. Water has the very special ability of being able to split apart the individual elements that make up any solid salt molecule, and hence the copper and the chloride atoms get split apart in solution, and they exist as ions in the water. That means that they float around separate from each other. We call it dissociation, and they exist as ions. An ion is an atom that has either gained or lost an electron and therefore has a charge, and that is why the solution is able to conduct electricity, is because these ions, which we refer to as electrolytes, are floating around in the water and they can conduct electricity. And here I've just got two other reactions that I did for the boys just to show them how electrolytes can react in solution. So I took an iron nail that's got a lot of the element iron in it, Fe on the periodic table, and copper sulfate. Now iron is more reactive than copper and will replace the copper in the solution, and hence what happens is you get copper being deposited on the nail and the iron, the elemental iron from the nail going into the solution. You can see from some of the different shots how the copper gets deposited and how the iron nail looks skinny after a little while when you put it out of the solution, as the iron from the nail is pulled out of the solution and pulled off the nail and goes into the solution. And what we are left with then is an iron sulfate solution, and obviously the blue color then disappears because the copper is pulled out of the solution, just like with the other reaction, and it goes clear.
And here is the what originally was a copper sulfate solution with the iron nail in it. Again, you can see hardly any blue color, and you can see all the copper deposited, and it's lost its blue color. So the solution that originally started as a copper sulfate solution with an iron nail, now we've pulled all the copper out of solution, so we have elemental copper, or the element copper, and the solution will contain iron nitrate. The iron being more reactive than the copper, it has replaced the copper in the solution. Then, and over here we go. I think we are finished here. You can see there is absolutely no blue color. All of the copper has been pulled out of solution and has been deposited.
Now the last reaction that I did in solution was with copper winding, that's the element copper, and silver nitrate. Now silver is even less reactive, and therefore the copper will replace the silver in the solution. So what happens with this reaction is the dry part of the copper that you can see sticking out at the top remains as the elemental copper, or the copper winding, and the silver ions in this case, which are positively charged, but they are dissociated and floating around in the solution, just like with the copper chloride, and they get pulled out of the solution, and what is effectively happening here is you are getting pure silver deposited in this, at the bottom of the beaker where the liquid solution is, and you are purifying silver.
And then the last thing I wanted to show you here, very clearly visible, that's the copper winding in this, what was originally the silver nitrate, and you can see very clearly how the copper winding that is dry, not in the solution, is still copper, it's still reddish brown colored, and all the silver has come out of the solution and been deposited there, and that is pure silver. And these ones also finished. So that is pure silver deposited at the bottom of the test tube there.
All of these reactions happening because of water being able to split apart the molecules that make up these solid salts, hence they make solutions and are available as ions to perform reactions in solution. Something that is very important about reactions that occur in solution is the fact that many of the reactions that are occurring right now in your body and that are keeping you alive are as a result of reactions happening in solution. Many minerals exist in solution that are transported around your body, as well as electrolytes, and the fact that they occur in solution means that things can be transported around and that reactions can happen faster because these substances can be split apart and exist in solution in a dissociated state.